Hello and welcome to this section of the Matlab tutor. In this section we're going to start to get into more of the symbolic capabilities of Matlab and talk about defining and using variables symbolically. So if you haven't already watched the section on dealing with fractions and symbolic math in Matlab, go ahead and do that right now and then join me back into this section because it's kind of prerequisite info. But in that section before, when we talked about defining fractions symbolically, we did something like symbolic 1/2 plus 3/4. And this symbolic command tells Matlab to go ahead and do the addition inside the parentheses, but don't treat them as 0.5 and 0.75. It tells Matlab to treat them as fractions. So when we get the answer, we get 5/4. We talked about how that could be useful to do fraction arithmetic. Now we're going to expand our mind a little bit and talk about defining entire variables that are symbolic, that can hold these symbolic things. And you're going to see quickly that when I say symbolic, it means it can store fractions, it can store polynomials, it can store anything that's not just a number, anything just that's broader than just a number. So the basic way you define a symbolic variable, I'm going to show you two ways to define a symbolic variable, just so that you're familiar with both of them. The first one is, if I want to define the symbolic variable x, then I would say x is equal to symbol x, like this. And when you read it literally, it makes a lot of sense. What you're saying is you take variable x and you're defining it to be a symbol that we're calling x. So whenever you hit enter, Matlab just says x is equal to x. All right, and that works fine. Defining variables this way is really the standard way in Matlab to do it. And when you notice that when you define this guy, when you look over here in the workspace, you'll see that x pops up as a variable and it's a symbol. So it's not a numeric value, it's a placeholder for some symbol. All right, now if I want to define y, I could do it the same way. I could type y is equal to symbol y, like this. Whatever you name the variable has to go inside of the quotations here. Well, the Matlab guys, they know that that's a lot of typing, so they created a shortcut to define symbolic variables. All you need to do is type syms sims space and then the variable name. So in this case, let me do y to make it different. And whenever you type that in, the variable y pops up in the workspace over here. So now we have two variables. One of them is x and one of them is y. Both of these methods are exactly the same as one another. Defining a symbolic variable this way and defining a symbolic variable this way, they're basically the same thing. And if you forget how to do that, you can go over here to the help menu and type in sims. You can see the function for constructing a symbolic variable. Hover your mouse. It says it's a shortcut for constructing symbolic objects, and it gives you the basically what we're doing on the screen here, sims and then the name. So that's how you define them. Now, what can you do with them once you define them? Well, you can store things into the variable. So let's say variable x is a symbolic object. If we want to store a fraction in x, then we would just say x is equal to 1/2, like this. Now we wrap the 1/2 inside of the symbolic thing because we want Matlab to store the fraction 1/2 in here as a symbol. We don't want it to store 0.5, we want it to store symbolic 1/2. So we do this and then it says x is equal to 1/2. Notice x is still a symbolic object. Okay, and so we were storing that symbolic object in there. So if we do x times 2, right, then we'll get 1. If we do x times 4, then we'll get something like this. Do x times 5, we'll get a fraction. So it's treating these calculations as a symbol. And when I say symbol, I mean not a decimal, in other words. It's doing the algebraic manipulations to give you the exact answer back. In this case, it's just 5/2. All right. You could do things like x to the 6th power, and it'll go and give you that as a exact answer back. Now let's say you make a mistake with the y variable here. Let me clear the screen. So notice we still have x and y. X has got the value that we just last calculated, 1/2. Let's say we're trying to store a value into the y variable. We accidentally make a mistake. We want to store 3/4 in there as a symbol, right? Because it's a symbolic variable. But we don't type, the SYM around the 3/4. We just forget about that, and we type in y is equal to 3/4. So you would think Matlab would treat it as a fraction, but when you hit enter, what MATLAB says is y is equal to 0.75, and it changes the variable from symbolic to numeric. So even though we defined y as being a symbol, when we set it equal to, see, MATLAB sees 3 divided by 4, it sees this as a math operation that returns 0.75. So when you try to store a decimal into a symbol variable, it's just going to change it back into a decimal variable like this. And you can see that reflected here. So if you try to do something like y to the 3rd power, you're just going to start getting decimals back. So that's very frustrating for a lot of people. You know, they define sims y, say, oh, it's a symbol variable. Y is equal to, you know, 1/100th. Okay, I want it to be a fraction, 1/100th. And then you say y to the 7th power, and you start getting all these decimals back. And it's like, what's going on here? What you need to do, if you ever make that mistake, is just go back and redefine your variable, sims y. This changes it back to a symbol, and then be careful. You just say y is equal to symbolic 1/100. And this tells MATLAB, don't put the decimal value of this guy into the value of y. Use it as a symbol and store it in the value of y. So now I get the value of 1/100th back, and now whenever I do something like y to the 7th, for instance, I don't get a decimal back. I get an exact fraction. Or if I do, you know, y divided by, you know, 24 or something like this, I get a fraction back because it's doing it all in terms of a symbol. And notice that y is still a symbolic variable there. So there is a very quick overview of how to define symbolic variables and the gotchas whenever you start assigning values to those variables so that they don't accidentally change back. Basically, whenever you define a variable as a symbolic variable, you have to do either sims w, or if you want to, you could say, you know, JSON is equal to a symbol, quote, single quote, JSON. Both of these things basically do the same thing. They return the symbolic variable back to you. And when you start making assignments, and if you want to maintain it as a symbol, then you need to be careful, because when you start storing values in there, if you really want it to be like a fraction, for instance, then you'll need to tell it, make sure that MATLAB knows to keep it as a fraction. So now if I do JSON squared, it keeps everything in symbolic form. And that's a good introduction of how to create symbolic variables and store simple values into symbolic variables.